This tutorial is a continuation for the previous tutorial where we are going to continue with example 5 part C. In this part we are going to find the integration of 2x squared all squared plus the square root of x plus 5 all divided by x squared with respect to dx. Then as you can observe, we have to work out a little bit inside the big bracket so we can make it more familiar for integration. We have 2x all squared plus square root of x plus 5 all divided by x squared. Let's first look into the first term and distribute the power to both 2 and x. Then it's going to be 2 squared or 4 multiplied by x to the power 2. This is the first term. It's equal to 4x squared. Now let's look into the second term, that is square root of x plus 5 all divided by x squared. We know this is a fraction that is having two terms in the numerator and a common denominator. Therefore, using the previous rules that we learned, we can say that this is the same as the first term divided by the denominator plus the second term divided by the denominator, as long as we have the same denominator. So we can write this form as the square root of x divided by x squared plus 5 divided by x squared. So now let's work it out more so it become more easier. We have the square root of x, it's the same as x to the power half divided by x squared. We can write it x to the power half divided by x squared. We know we have the same base using the indices rule. This can be written as x, the base, to the power, and we now subtract the powers from each other. Half minus 2, so it's going to be equal to x to the power. We take 2 common denominator, 1 minus 4, then it's equal x to the power minus 3 over 2 using the indices rule. So the first term in the bracket is going to be x to the power minus 3 over 2 plus 5 divided by x squared. X squared can go to the denominator and we change the sign of the power, so it becomes 5 multiplied by x power minus 2. This is more familiar form for us to integrate. Let's substitute it, so we get integration of 4x squared plus x to the power minus 3 over 2 plus 5x to the power minus 2 all with respect to x, d of x. Therefore, let's do a straightforward integration for the first term, that is 4x squared. Then it's 4, the constant, multiplied by x to the power n plus 1, which is 2 plus 1, 3, divided by n plus 1, that is 3. Plus, for the second term, x into the power minus 3 over 2 plus 1, this is equivalent to n plus 1, then it's equal to minus 3 plus 2 over 2 equal minus half. It will be minus half x to the power minus half over minus half. The third term, 5 to the power x minus 2, it's 5 multiplied by x into minus 2 plus 1 is minus 1 over minus 1 plus a constant. Let's do some simplification. Then it's 4 over 3 x to the power 3 plus, we have in the second term in the denominator 1 minus 1 over 2, then we take its reciprocal, so it becomes 2 or minus 2 over 1 multiplied by x to the power minus half plus 5 divided by minus 1 is minus 5x to the power minus 1 plus the constant. Let's rearrange it or write it in another way. So it's 4 over 3x cubed minus 2 multiplied by x to the power minus half. X to the power minus half is the same as 1 over x to the power half minus 5 to the power, or multiplied by x to the power minus 1, it's the same as 1 over x plus the constant c. This is equal to 4 over 3 x cubed minus 2 multiplied by 1 over x to the power half, which is equal to square root of x minus 5 over x plus c. This is then the final integration answer, integrated answer. In this part C, we used another strategy. We used first for the first term the indices rule, and then for the second term we divided terms of numerator by the common denominator. By the end of this exercise or example 5, we can summarize the strategies that we used in order to do the integration. For the first part or part A, we worked with indices. For part B, we expanded the expression. And for part C, we worked with indices and divided the term of the numerator by the common denominator.